Problem 5 is a rocket problem. So we've got a rocket out in space, right? It's in deep space, and because it's in deep space, we can use this equation that does not have gravity in it. Okay, and it's got some exhaust coming out. And the exhaust on a rocket comes out at really high velocity in order to provide you with the propulsion that you need. And this rocket starts off at some initial velocity VI. It ends up at some final velocity VF. The rocket fires for some time delta T. This is its initial mass, MI, right? MI right there. And it used 70.9 kilos of fuel. So that's a change in mass, right? And we know we're going to be using this equation. We don't have to worry about gravity because we're in deep space. The final mass we're out is just going to be, our initial mass minus the fuel we burned. And so we now have our initial mass. We know that that's given to us. We have our final mass because we've got how much we lost. We've got our change in velocity because we got our final velocity and our initial velocity. And we're after U here. All right, so let's go type this out. Okay, so our change in velocity is going to be v final minus sign v initial, and we know final is 1055 meters per second. V initial is 814 meters per second. We know our initial mass that's given to us. That's our 1288 kilos. The other 8. We know how much mass we lost because that's 70.9 kilos. And so our final mass is just our initial mass minus the mass we lost. And we're after U, the exhaust velocity. So if we solve this equation for U, U is delta V divided by natural log of MI over M. Right? And so now we have everything. V final minus V initial divided by log of MI over MI minus delta M. And there you have it. And you've got the exhaust velocity of the rocket. And again, key in this, it's in deep space, so we don't have to worry about where gravity is in this one. And we're done. Good luck with problems.